As Azam said, last week we were focusing on. So I did a brief presentation on the pre-processing stage of neuroimaging and how our tool was going to help neurologists move quickly and move faster in a positive direction. And then we had Helio presenting last time as well from York University. So he had that presentation with the wheelchair. But from this week onwards, starting now, we will be going back to our previous format, which obviously involves modeling and programming. So I will just quickly hand it over to Azam again.
Thanks, Amal. Uh, Now, today I am starting about some revision work about the pre-processing of data pre-processing, and further, today I am thought about some important things like how we evaluate our model and which evaluation metrics are used for the evaluation of the model. But firstly, we visualize some data models, how we visualize our data model, and some steps regarding to the pre-processing of a model. Uh, in last week, I am giving the some assignment work for the people regarding important data set or Titanic data set. And wait, I share my screen. You see my screen? Everybody see my screen?
Yes.
Yes.
Yes. Okay. Uh, Last 2 weeks ago, I am giving some little bit assignment regarding the understanding of the data set. This is not too much difficult assignment. Basically, the motive of the assignment is that how we read the data and which attributes we are taking from the modeling of data. In such case, we discuss about the Titanic dataset. This is a dataset which is basically made on the Titanic ship. When this Titanic ship is drawn, what the circumstances and how the attributes give the collective dataset from the Titanic regarding the people who onload on the Titanic. And in this dataset, we basically observe the attributes of the Titanic dataset and mention that how these attributes are important from your point of view. The basic assignment is that you pick a dataset and choose some attributes from such datasets and uh, brief that how why we choose such attributes from such datasets. And next thing is that you observe that either the dataset is a clean dataset, now you further pre-process such datasets. And finally, you decide that which type of problem you conclude that in dataset, either it's a classification problem, either it's a regression problem. And this I also predict a solution for you people because only 2 3 guys send me through email the solution, but I conclude the solutions for you people. First of all, we take some important attributes uh, from Titanic dataset. Basically, the target field is that the predictive is the how many people survived in the Titanic case. First of all, we take a P class attribute. P class is a attribute field name, but basically it belongs to passenger class. And I take this field because we can indicate that the social economic status of the passenger, which class of people are on load in this ship. Secondly, I take a sex field. Basically, this is the discrimination between the survival rate, either male, either female people are survived much in such case. And the third is the age factor. It's also very important field because Many young people, childrens, and the people old age are also onloaded in such ship. And in the fourth attribute, we take the SIB. It's mean that the number of siblings and spouse are in your ships along with the family members. And the five is the Parsh. Parsh means the number of also the number of parents and children abroad, their family. And in the sixth, we take a fare because the fare also can indicate the social economic status of the passenger, which type of passengers are onloaded in the ships. Either they belongs to poor family, either they belong to very rich families, other we are in between. And the last field I took is the port or embarkation, mean the port which the passenger boarded now. There are different areas people are boarded in the ship, and we conclude also that which fields are this less important attributes from my point of view. Like passenger ID is does not directly belong to the survival case, and second the name of the person because ABC any name person are loaded in the board is does not indicate the survival, and third is the ticket, and the four is cabin. Cabin is also important, but in our case many missing values are available in datasets. That's why I cannot take such field. And the initial observation is that uh, there are many missing values in the age and cabin and in bar column. That's why I firstly I clean such value by applying the EDA process, handling the missing values. So first of all, uh, we take a mean, median, and predictive model approach to the missing values. There is somebody join us. Now, secondly, the feature engineering the values because in some cases we concatenate some two fields to one field, such like that. In our case, we take SIP, SP, and pass field to a family member field. And thirdly, we also convert our And thirdly, we also convert over all the fields which are in the string value and numerical in the character value to numerical value. Just like that, in the dataset, we have a sex value in the case of male and female. And now we put in encoding to such field from 0 to 1, either male given to 0 and female give to 1. And similarly, in bar field also the port of destination which we also inputted to the numerical values. And now we also calculate the outlier reductions. In the previous lecture, we also discussed the outlier. Outlier basically the such values which does not belong to the data sets. Such like that, if the fare goes to $1 to $50 and the sum value occurs like 500, like 200, this is an outlier because the fare is between 1 to 100 and 1 to 50, and this value are not in the particular range, and these values are called outlier values. And next, we also scaling and normalize our data set. This is also important feature. We also apply on the fare and age. And at the last, we indicate that the target field is the passenger survivor value. Either the value, if the value predicted the model is 1, it's mean that the person is survived. And if the values predicted the model is 0, it means the person is not survived. This is basically uh,
Azam, sorry to cut you. I just have a quick question for you.
yeah.
When you mentioned fear, can you talk a little bit about that? Fear?
Fare mean the passenger uh, payment of the
Okay, okay. It's referring to the bus fare. Okay, I got it. I
Okay.
got it. Okay, thanks.
Uh, Now in the last we discussed that we decide that either this is a regression problem, or either is a classification problem. Basically, when we made a model, first of all, we decide that according to the data set, either it's a regression problem, either is a classification problem. Now I define both the things. Regression problems are such type of problems which deal on the continuous data sets. Just like that, the time, just like that, the house prices and some other like stock market share prices. These all values are belong to the continuous type data. Means the data is belong to continuous values. Not discrete. Discrete values are like 0, 1, 2, but the not included in the decimal values. But the continuous values belongs to 1.1, 1.12, and similarly up to the 12 to 13 decimal places. And the other side, the classification problems are these type of problems which we conduct a prediction about something. Just like that, if we get a data of emails and we conclude that how many emails are spam and how many emails are not categorized in the spam, then we have two type of categories. These Titanic model is also belong to the classification model, because in such case we have two values: either the passenger is survive, either the passenger is not survive. That's like problem are belongs to the classification problems. And in some over case we have a binary classification problem, but in many cases we have multi-class attributes and we have multi-class classification problems. And in the other sets, regarding to the narrow diseases, we also have many multi-classes belong to such diseases, and such problems are the classification problem. In real world, basically we are dealing more like classification problem rather than to the regression problems, because regression problems are not too much famous as like to classification models, because many models are basically belongs to classification data. Now, in our case, how we train our data, we made a EDA steps. First of all, we load our data sets, and secondly, we handle the missing values, and third, we also apply the feature engineering. And at the fourth point, we convert categorical data to numerical values, and then we scale up and normalize our features, like removing the null values, and we take some mean median modes, just like that. And on the other hand, we define a target variable which we categorize in the case of binary problem. Then we split our model in the training and test sets, and then train our model. This is basically about the assignments solution which we are
Azam,
giving.
I have a question. So, how do you differentiate between training and testing sets?
In training sense, if we have a data set of, let's suppose, 10,000 parameters, then it's the formula that we split our model in 80-20 ratio, the 18-50 ratio. We conclude randomly 15% to 20% of as a test cases, and train our model remaining that data. After the training of data, we apply algorithm from our model, how our model predict from training and testing. And this is basically the evaluation of our model in the real time. If our model is giving a 90% accuracy, but in the test case our model not performing the 90%, this is in some cases when we have not balancing our classes of our data, we take Uh, just like that, if we have example that we have a 10,000 data of of mails like spam and not spam, but in the data we have 80% mails are regarding to the spam and 20% mail regarding to the non-spam category. When we train our data, our model giving the prediction like accuracy more than 90%. But in the real case, when we predict our data and we give the values of real time, our model most likely most likely giving the values which are not spam, because our model basically mostly train on not spam values. That's why in when we train our model, we firstly uh, we decide that we in balancing our data is very important thing. In the future, when we train our model, we also discuss such things.
Okay, okay, got it. Thank you.
Okay, now I am starting today presentation. Now today presentation regarding to first of all which type of problems. There are basically two type of problem: regression and classification problem, and how we predict that these problem belongs to the regression and these problem belongs to classification. First of all, we get a data, and after analyze the data, if our data belongs to continuous numerical values, it means that we made a model of regression model. And if our models are based on discrete category label values like zero, ones, and different values, then we made a classification model. And real world, the models are like time series model, like temperature and other things which are decimal values or continuous values which are belongs to regression models. And similarly, the classification like binary, like multi-class models belongs to classification models. An example is that house prediction, temperature forecasting, and in the other case, in the classification like email, spam detection, like disease diagnosis, these are that relate to classification models. And on the other hand, the model outputs. In case of regression outputs, we have unbounded numerical value. Like we guess that we have a value of 10 point something. We have other things which have decimal values. Such values not unbounded. Uh, and in classification model, we have a probability opportunity. Probability basically belongs to the number of chances and the number of chance between 0 to 1. This is a probability statement. And in case of classification model, we also believe on the probability theory. And similarly, in the regression, we have evaluation matrix of MC mean square evaluation, and MAE mean absolute error. These are two basic evaluation metrics which are concluded in the regression. Some other metrics are also RMSE and R2, but these are not mostly used. Mostly used are MCE mean square error and MAE mean absolute error. And in the classification type, we have basically four major classification evaluation metrics. First is over accuracy over a model, and second is precision, which is also we call sensitivity, and third is recall, and fourth is F1 score. ROC is also a graph curve, which is also implemented in some model. But the four things are very necessary for the classification model. And this is in the machine learning terms, we call that classification report. In classification reports, when we apply the classification report method, it conclude all the four figures: accuracy, precision, recall, F1 score. And now, which type of algorithms we are using for the regression and classification problems? In regression, we use linear regression, decision tree, neural networks, just like that. And in the classification, we use logistic regression, SVM, random forest method, neural network, deep neural network. These all are used in such case. And in the decision boundary, in case of regression model, we have a line and curve which we draw that, and in case of classification, we also draw a line some other uh, evaluation graphs when we working on the models. Then we learn about which type of graph and which type of plot are necessary for the decision boundary. Now we move forward. Now we first of all we have first of all the evaluation metric. The first evaluation metric is accuracy. How we calculate the accuracy? Accuracy basically ratio of correctly predicted instance. Instance means the values which are we doing in case of you are doing the images are your values, and when we use a numerical data in a digital form data, all the rows field are your instances field. Now, in last example of Titanic example, over predicted instances are your survival rate. Either your survival rate is zero, either your survival rate is one. This is your accuracy. Accuracy formula is the number of correct prediction divided by total number of prediction. You see that we have a value of TP. TP means true positive. True positive means the value you are predicted and also the value are truly predicted. These are the true positive values. True negative values, you predicted that the values are correct, but basically these values are not correct. These are negative values. These are called true negative values because your prediction deal that these values are correct, but in real world these values are not correct. Similarly, the false positive, the values you calculated that these values are false, and you also predicted such values are false. These are false positive. And similarly, false negative, the values positive cases, but incorrectly we predicted that the negative values. Means that if somebody have a cancer, but we predicted that the person have not cancer. This is basically more dangerous thing in case of medical field because false negative is very dangerous field, and the perception value is also calculated such that in the if we in such slide when to use accuracy, why use, and when to avoid the accuracy. First of all, we balanced our data sets. If our data set is not balanced, it doesn't mean that our accuracy is more than 90% because when we testing our case, most of the tests are not correctly evaluated. In such case, we balanced our dataset. And how we can balance our dataset? There are different ways. We create imaginary noise. We create a dummy images, dummy values. In case of digital value, we calculate a mean, a median, a mode of the values and put these values on such category, and these mean and values are calculated from the values available for us. Similarly, in the image cases, we calculate the pixel values of our data sets, which classes are too much low value, and we made a noise, create a noise on such images and create such type of images, imaginary image for the balancing over a class. But there are some other algorithms that uh, unnecessary noise also creates some problem for the prediction of a model. These are discussed in further. Now, when to avoid over accuracy, and this thing is that in which cases we avoid the accuracy, we avoid over accuracy in imbalanced data sets. For example, that we get a 95% example of negative values and we train our model. Our model gives me 95%, 95, 96% accuracy because all the values are relating to one category and accuracy level is too much high. But when we give a positive value to our model also predicted that in negative case because all the models are trained over negative value. These are the major things which are dealing in the professional level because in your level, in the research level, mostly people are moving through their model give a higher accuracy rate, but evaluation rate, I believe that in that accuracy you have already also have the precision recall F1 score is also in a good value if your model is good trained. If your model is not good trained, these values are relevantly not match to your accuracy. Now I stop at level. If somebody have a question regarding that, ask me.
Okay, Azam, I have one question. So, when you say it's good to have a balanced data set when we are training the model, so does that mean that we have how would you define a well-balanced data set? That you have a certain percentage of positive and a certain percentage of negatives, or what is the definition?
Uh, in case of I take example of Alzheimer. You see that in case of Alzheimer, if we take Alzheimer data set, we have four types of categories of Alzheimer. First is mild category, moderately mild, non-dementia, and dementia category. But if we take a data set, in most of the cases, the mild category values are too much low as regarding to the dementia and non-dementia category. In our cases, if we took a dataset of 10,000 images and we have all of dementia category images are, let's suppose, 3,000 to 4,000. And similarly, we have the non-dementia category, we have images of 3,000, 4,000. And regarding to categories like mild category, we have already also 500 to 600 images regarding such category. Now, this is imbalancing of our classes because two classes are too much high and two classes are relevantly not match such data because one class is regarding 1500 and one class regarding to 500. Now, in such case, we apply algorithm like Gaussian noise algorithm for our data set. In Gaussian noise algorithm, over the values of our images like 500, the Gaussian side gets these images and take the size of other classes, matches such images and create and just like that the imaginary images which are not in the real dataset, but for the training of our dataset, it also reside in the memory like in data frame. That's a technique we made imbalancing, handle the imbalancing categories of our classes.
Okay, got it. Thank you.
Okay, now I move forward. Now in the second, uh, now the second evaluation metric is classification model. Is like perception. Perception is also called sensitivity. The ratio of true positive to the sum of true positive and false positive values. The formula is also done that true positive is the values which are correctly evaluated over a model. These values are called true positive, and we divide the true positive and false positive. False positive is the values which are the false values, but our model predicted as a positive. These values are false positive. We sum that values over our true positive values and calculate a ratio. If our ratio match percentage to our accuracy, we conclude that our model is rightly predicted the things. But if the value is not matched to our accuracy, not same like that, you see that if our accuracy is like 95%, and our precision is 92 and 92%, it's good, because sometimes some other factors are involved in such cases. But in such case, the model is not rightly tuned, and after some training values we also fine tune our model. But in the first case our model is rightly tuned. But in case our precision value is given to 70%, 80%, it's the alarming situation. It's mean that our model is not rightly uh, tuned that. And when we apply our model in the production values, and somebody gave a test values for our model is not predicting. Our model is just like that overfitting the values, because the values are not regarding such category, and our model assume that these categories are too positive. This is basically we need such evaluation metrics. And another evaluation metric is recall. Recall is that the true positive values divided by true positive and false negative. False and negative mean the values are already false, and we incorrectly uh, conducted that as a correct value. The positive case is incorrectly predictive as a negative. Means that our model is in the underfitting condition. Like the cases are positive, just like that somebody have Alzheimer case, but our model predict that the person is not Alzheimer. This is very critical in production point of view, because somebody have a disease and our model directly predict that the person have not disease. This is an alarming situation. And these things are most probably evaluated in the explanation AI cases, because just like prediction of the model is not good in the medical case, in medical cases we also elaborate our models and elaborate all the MRI images with the help of explanation AI methods and other some other approaches which are also belong to explanation AI. This is a new uh, prediction policies, just like the interpretation of our inference of disease. And mostly models in the medical fields are tuned in such like that. And the last evaluation matrix is F1 score. The F1 score basically the harmonic mean of precision and recall. It balances the recall, precision, and recall. Basically, these value create a balancing between the two ratios. You see that the formula is 2 multiply precision multiply recall and divide by precision plus recall and equal to total positive. This is the other way. If you simply calculate the value, there are two ways to calculate the formula. The other way is you directly get the value of true positive and divided the false positive or false negative and divided by 2. This is the other case. And the interpretation is that your harmonic mean, extreme value, more arithmetic mean. Basically, it's just like a arithmetic mean formula. You have a values of different things, and you get the average of the values and divided by the total number of the values. This is arithmetic means. Just like that, the harmonic mean is also calculated in such like that. And the answer is over is between 0 to 1. 0, the values goes to zeros, it means worse, and values belongs to 1, it means our model is best. It means that if our model's percentage is 0.9 and percentage 0.85, it's our model is best. But if our models give the values more than less than 50%, yeah, 60%, it means that something wrong in our model. Now, the other thing, the evaluation metric of regression model. Basically, regression models are not toughest model. These models are not in the real time examples. are done. The first formula of regression mean absolute error. Mean absolute error basically the average magnitude of error in the set of prediction without considering the direction. The formula is that not a uh, basically these formulas regarding to the statistical formulas, and in the next lecture I brief all the formula in the best way. Now we move to the practical work. We basically in last lecture we also visualize some plots on the pre-processing of data. Now for the practice point of view, I make a stream for you people how we visualize our data from pre-processed data sets, and after the visualization of data how we put our data in simple model. This is basically practical point of view for you people, and I also upload such things on the GitHub. Uh, if you have some question regarding some point, that now we start our uh, practical work.
Yes, I do. Not the practical work, actually, about the correcting the data set.
Okay.
So,
Now I am starting the practical work. First of all, we
hello.
import some, yeah, Zayan.
I've got a question about the data set cleaning.
Okay, ask
I
me.
so Yeah, so I was wondering, how do I what is the tool I use for recalling precision and like cleaning data sets in general?
In
The
general, the
tool.
basic thing is that we take a EDA process of our data sets. First of all, when we make a model, there are three phases of making a model. First phase is that we we take a example of real-time problem, how the real-time problem, how we solve such problem, and we take a data set from such solving of such problem. You see that in case of Titanic, we get a data set of the person which are on board on the Titanic board ship, and we get a data sets of such people. And I think so, just like 800 rows data sets is available in such CVC file. And then we apply EDA process on that. We apply that first of all, we get a feature values, feature attributes. Feature attributes means which values which are getting from the model for the training of a model. And we get five attributes, we get four attributes. It depends upon you. When we get more attributes, you justify that in your model. The model which are trained more attribute is more reliable. The model which is based on less attributes, its reliability is too much distinguished. Is not up to the mark. Now, after the pre-processing, we built a model. Second phase is we built a model. We categorize our datasets in training and test phases. You see that if we have 800 records, we split our model 600 records to training side and 200 records to testing sides. And after some uh, available theorems of models like regression model, logistic model, like neural network, like decision tree, and other models like CNN models, deep learning models, we trained our models. And after the training, we apply such evaluation metrics on our model data, like accuracy of our data, like precision of our data, like recall, and like F1 score. When we make a model, I also give some reliable examples, and you also makes uh, examples, put examples on such datasets. For your own datasets, I guide you, and after that, these all things are clear you, because these things are parameter of your model, how your model gives the accuracy, or your model treat in real time values. Are you understand?
Yes.
Okay, now I move forward. First of all, I take import a NumPy library. NumPy library is a library which we got from the numerical values, and Panda library is used for the um, plot for the data frames or the loading of data set. And matplotlib is a library for the plot of graphs and something. And other library like sklearn. Sklearn is a library which is used, which have a built-in pre-processing methods and built-in pre-processing algorithm like logistic regression, neural networks, also available in such library. Seaborns is also library which is using for plotting, and this is some other thing. We ignore the warnings and other things that we apply some filter that the ignoring are ignored in our cases. Now we start that uh, we process that, and you see that in seaborn we have different type of plates. We have deep, muted, bright, pastel, dark, and different plates, and we get one plate of that for the coloring of our plots. And you see that we take a color plate, palette plate, and the other plate we take a reddish plate, and further we take color bind plate. These are different type of plates we are getting on. Now we take example of a Titanic dataset, how we pre-process our Titanic dataset in real time. Because in such case, in such example, you have an idea that how we clean our dataset. You see that first of all, we put a indicator, available indicator in the our dataset like survive. It is a field which are our target field, p class, name, sex, age, pass, ticket, fare is a mean amount paid by passenger, and cabin and embark. And then we load our dataset. Our dataset is in the dataset folder, and we give the path like that dataset and the file over dataset. And read CVC is a method of our Panda class which load the dataset in the case of frame. This is a basic step how we load the digital data. All the digital data either is a CVC file, either is a text file, also load through Panda library. Now we shape. Shape is a mean that it provides me that how many columns and how many columns and how many rows are available in our dataset. You see that 891 rows and 17 columns. 17 column means 17 fields are available. Yes, 17 features are available in our datasets. These are the features: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the features. And after that, we have a command of head. When we give the command of head, it gives the first 5 rows of our data set. And you see that these are the first 5 rows of our data set, the serial number, passenger, survive, and other things that. Now we plot a distillation plot on our data set. We take a parse field and apply a histogram data set, and this gave the values of the parse. Parse means is a place where the passenger loading road, number of parent and of the passenger. This is like parse field, and you see that this is the category of the passenger, like that the count of the passengers, and these are the values they are available in data set. Now we move forward. We plot another graph. This plot graph, and this plot graph is applied on age. And you see that after applied that we have a parabolic shape of that. This is also indicates some features regarding the data sets. And after that we also apply figure this plot graph in such like that, and this is also a parabolic shape. And after that we apply a rel plot. This is also a plotting of different classes at a time. In first we apply age, and secondly we apply a fare. This is basically a comparison between two or more classes. And in case we make a comparison of three classes, three types, like age, like fair, age and fair comparison. How many age person? This is a scattered graph. This show that how many figures are deviate from each other. You see that these figures are outlier because the fair is between just this like that, and the figure is like 550, and this is outlier. This is another way to outline your outlier values through graphical values. And similarly, you, if we move forward, this is a value show that the outliers. We show the outlier of age. You see that these are the values which are showing you. Similarly, the other graph you also right. This is basically a line graph, and after that, this is a major graph of heat map. Heat map is a graph which also show the confusion matrix. These graphs are also used in the real time, and we move forward in faster way. And now I clean over data sets. How we clean over data sets? Similarly, that we this is a basic process of cleaning a data set. We load over data sets. First of all, we give a shape, how many rows and how many columns are available. Next, we have a other command like info me is a command which also give you the basic structure of your data set. You see that the age have 714 values. It means that more than approximately 200 values are null values. Similarly, the cabin values. Cabin values are 204. And you see that these values are also null values. And after you apply such commands, you have an idea about your data set. And how you see your missing values, you apply is null value is a already a function available in the pandas library. And when we apply a library, you see that the age factor has too many missing values, just see that. And cabin has already too much missing values, these java, and these are not missing values. And after that we apply such formula. These are the basically graphs. Now Now we apply the categorical values, how we convert category values to or values to over numerical values. You see that age and P class, those two values are available in the have some outlier and some null values. And we apply a method. This is a method impute age which calculate the average age and puts the value of age in null values. After that, we have apply a formula like drop. Drop is a formula apply on a cabin field because we remove such feature from our dataset. And this is the method. Drop method is a method which is applied on the cabin field, and accesses mean that only the column is removed, not the row. Only the column cabin is removed from all rows. It means that 891 rows approximately rows, and the column is on. Now we have 11 columns. After that we apply another function. This is a values, drop values, all the values which are missing drop for just function. We apply all the values which are dropped, cancel. And after that we have 889 values, 889, and this is the form of our cleansing data set. This is the process how we clean our data set. This is one way. Another different ways are available in examples, and I am giving you some other examples for cleaning of data set. This is one example. We use some built-in functions also available in scikit-learn library. But in case we are not uh, using some built-in functions, we use some pandas functions, basic functions from the cleansing of dataset. And after the cleansing, we convert sex and embark value to categorical value, categorical value to numerical value. This is the way we convert that. You see that we convert zeros and ones from convert categorical data types to numerical data types. And after you see that when we apply such function, our values are these are our values. When we apply that, after applying that, wait a minute, I apply in such case. And these are some other examples where when we model for the ready of your model, and you see that when uh, I see you how we convert our values to numerical. This is, you see that these values are male and female, and these values are and bark are also available in SC and SC, and we convert into digital values. Now we move forward. Uh, these parts are not covered today. I am because this is building our model, but I am giving you all the code for you people. You just run this code on your side, and after running your side, you have an idea how we made a model. But in the next lecture, we give you the detailed point of view how we made a model in real time. But this is a just an example for you people. You just see that examples how the model is building that and how the other things are applying on that. Now, similarly, that we have a good example for you as regarding to the images, because in the real time we are doing to medical diseases, and we are mostly dealing with images like voice images and 3D images. Now I also built an example for you. This is just like not a very tough example, but as a observation, yeah, as a understanding point of view, how we deal for the images. This is a good example. At just such point, if you have some question, you ask me, then we elaborate such example. Ahmad, you have some question regarding that? I think Ahmad is not here. Mayan, you have a question? Are somebody here? Are you hear me?
Yes, yes, yes.
You have some question regarding such point, because in next phase I am elaborating how we deal the images in such example. I am choosing a dataset of digital dataset from handwritten datasets, and we apply the neural network on that. Firstly, we apply some data pre-processing method on that, and in the real time, we apply a neural network. And after applying neural network, we predicted that how many cases on model real time predicted through. This is our basic goal, because these type of model we are dealing in the future, like medical diseases.
Great, thank you. So that will
Okay.
be next time, yeah?
Yeah, because we are dealing
Yeah.
mostly in the diseases, and we mostly deal with images. These are just like 1D images, but in our case, we deal 2D and 3D images also. Because firstly, we started directly from the MRI, but many of the students do not understand the basic things like how we pre-process the data and how the evaluation metrics are available for the pre-processing. That's why in the last few lecture, including this lecture, we are elaborating some basic things, and I think that most of the students have the idea that how the machine learning works, that and how the process is for building a model. Now, in the next few lectures, we are dealing such some real-time data images, like images of lung images, like other disease images. Now, and after that, we are moving to our major goal of MRI images. That's my and
Great. Thank you.
the main thing is that you must practice such thing in your side. Practice is that uh, the code I am uploading in the GitHub, you must run this code on your side, and you have a problem during the running the code. You must ask me through WhatsApp, yeah, through email, yeah, the other way you are feasible for that. And before the class, you collect your problem and you have work on that. That's my goal.
So our assignment is gonna be like cleaning data sets using the code you're gonna upload on GitHub.
Yeah, yeah. I am giving you today another assignment regarding two free data sets, and you apply a cleansing on that data set, and after cleansing, you visualize some plots on the such data set. But, but this is example. Now we are working for you for images. This is a high level example, not too much high level, but this is understanding how we deal for images. Because in real scenario, we also deal with images. We are not dealing like just like CVC and just like textual data. Because the machine learning models nowadays building for computer visions mostly deal from real time videos, real time images and other like stuff that. Now start that. First of all, we import some library. We import TensorFlow. TensorFlow, there are two types of library which are dealing uh, for the modeling of our data sets. First is TensorFlow. TensorFlow basically the Google library, and the other is the library PyTorch. PyTorch is a Facebook community library, and many computer vision models also building in PyTorch. Both libraries are too much methods and too much facilities for the evaluation of a model. Um, because the TensorFlow is slightly easy as compared to PyTorch. Now we start from TensorFlow. We just like install, package install, pip install TensorFlow, and TensorFlow install in your site. And after installing that, we import the library. NumPy and Matplotlib and such library are also installed in your site. And first of all, you see that in TensorFlow we have already available data sets. Kara is a library which is built before the TensorFlow, but nowadays Kara is already embedded by TensorFlow. You just need install TensorFlow. Kara is already installed inside the TensorFlow, and we get a dataset for Keras because Keras have many datasets. Uh, I Keras datasets. You see that when we go to the Kera side, we have a different type of datasets. We have I choose minus digit classification datasets. These datasets is belong to handwritten digital digits, and other datasets is CFR tens. These datasets belong to small images of different objects, 10 categories objects. And CFR 100, this is the dataset of 100 small images of different objects. Just like that, movie sentimental analysis dataset, fashion datasets, California house prediction dataset. These are the datasets which are freely available for Keras, and these datasets are also freely embedded in the TensorFlow library. That's why I just load the dataset from. Do not download the dataset from directly and put in my datasets. We get the dataset from the built-in library like Keras. This I import that, and after import we load the dataset. You see that we we load our datasets and split our dataset X train, Y train, X test, Y test. This is a categorization of our datasets and split our datasets in the form of training and test. In the previous, Sir Ahmed also asked me a question how we put our datasets in categorize our dataset, split our dataset, and this is the practical example how we put our datasets from in the real time. We categorize our dataset in a train and testing model. You see that X train mean X values variable, Y train mean Y values. Y values are the values which are in a vertical way. X values are in the horizontal ways. This is the basic plotting of the values. X test similarly the test values and Y test is similarly the Y value. And we load the Manish dataset. The first line, one line we get. Wait a minute. I think I don't know why the people are left the meeting. Either I think
No,
so in
no, I rejoined again because of internet connection. I just refreshed the page as if your voice was
I
not.
think
Okay, Mustafa is back. Yes, he refreshed the page.
okay. Okay, the first line is that how we upload the image dataset directly from the X train and Y train and separate tag. In first line, we load our dataset and also split our dataset in the training and testing point of view. And after that, we apply. Uh, Sarah is also join us. And after that, we print the dataset shapes. How many shapes are available in how many times? You see that in training shape, we have 60,000 images. In 28 by 28 means 28 by 28 pixel, and X pixel and Y pixel, because this is a 2D image and 2D black and white image. In case of RBG's color, one value, the value is in the case of 3 times. One value multiplied by 3 is also available in that. But in case of grayscale, is also give me the two pixel y-axis pixel and x-axis pixel. And these data sets basically also uh, in the form of pre-processed form, because we get a dataset from a Keras library, and you see that all the images are already resizing in 20 by 28 by 28. And similarly, we split our dataset as a 10,000 images in the test case. Basically, we have 70,000 images. 60,000 images are in training, and 10,000 images are in the um, test phase. And first label, we calculate that the value, just like random value, the first value label is 5. If we give a one value, you see that we have a label of 0. If we get a value of 2, because these values are get from randomly, you see that the value label is 4. This is basically proof that your dataset, uh, count of your dataset and labeling of your dataset. And after that, we made a method for plotting of such images. You see that five handwritten digit also label 5, 0 also label 0, because these labeling are already provided by the caras for your instance. But in our case, in our real time scenario of MRI, we put the effort for making a data set, because in a real time uh, there are lot of effort put on the pre-processing and the cleansing of data set. But when we get a data set from the training point of view, these things are already prepared, yeah, already available for you in the furnished form. And after that, we apply a normalization process. Normalization is a process which also pixelize the data between 0 and 1, because our uh, data are pre-processing and the backend of the computer size in the form of 0 and 1 pixel bit format. One bit is on and one bit is off, just like the scenario. And now we reshaping our data. We reshape our data. You see that we reshape our data in that we reshape 20 by 28 and one mean this is a grayscale. And after that, this is a one hot encoding level. This is also a technique which is applying for just like for the normalization shape, but this is applying from for further pre-processing of our data. In a future lecture, I also discuss this how the one hot encoding is working that. But in such case, we also apply that one hot encoding on that. After that, you see that over X train is 60,000, over Y train is 60,000, and 10 is that over label means that 60,000 data has 10 label values 0 to 9. And similarly, the over text case. After the finalization of data, we apply a model. We apply a neural network model, because this neural network model is already available for me from a class I show you TensorFlow, because we also choose a sequential model from TensorFlow. But TensorFlow already builds too much model in backend. We just give the parameter values and neural network built from me. First of all, we give a input of our values. Our input of values is this is very important. You must you must give the input of your shape. That's why I am printing over shape, because training our model we must print that which shape is I am giving from your model. You see that the 20 by 28 is a flattened 784 pixel. How is the pixel is calculated? 28 multiplied by 28, you get a pixel of your whole image. After that, we apply a dense on that 128 dense, and this is the activation. These things are also elaborated when we move from neural network. And the second is dense is 64 dense, and last dense when we apply bake a neural network, the last dense is a dense which is belongs you to your labeling of your category. If your labeling of your category is 4, your dense is 4. If your category is 100, your category is you just put in the 100. In my case, my category has 10. That's why I am giving the 10 in the dense case. And after that, we move forward. And this is the method which are previously I am not uh, basically this is the tuning of hyperparameter which are giving from the tuning of a model, because I am not elaborating such things. In the next lecture, I also elaborate such thing why I am using the category catastrophe, why I'm use learning rate, why I'm use optimizer Adam, and how many type of optimizer are available in that, such like that. Now we put a summary, and after put a summary, you see that this gives me that we have trained 109386 parameter, and just like small size for 27 KB is the size of our model. And when we put a training over model. This is a basically real-time training over model, and you see that the accuracy and loss and also all things are calculated on our epoch. Epoch means the loop. I take 10 loop on that. And badge size mean how many badge are manipulated in one turn. In one go, I take 0.64 badge. And split means how you split your I splitting in a 20% splitting. After that, you see that my accuracy is 96.60. After that, we apply some other plots. This is the basic plot which are giving you how your mother are treated like that. You see that our blue line curve touches to the 99%, and our validation accuracy curve also between 96 because 0.03% deviate that. This is not too much. But if our accuracy is like validation is touches to 80s and touches to 85, this means that our model is not finely tuned, that the data set is not we again pre-process our data, and there is some abnormalities and some outliers in there. Similarly, the loss, you mitigate the loss. Similarly, you see that our loss mitigation is 0.001%. And similarly, the validation is also mitigate that 0.010. And after that, we apply a real-time test on that. We take a 1000, we take a images of 313 images and apply a test on that. Uh, you see that after plotting that, this is a real-time scenario of our model. First graph, we plot that actual versus predicted. We take actual value, you see that actually we take zero value and predict zero value. Similarly, actual we take three value and predicted three value. Similarly that, but in such case, you cannot analysis that how which value is wrong. You give a color from that value which is predicted wrong. And similarly, we apply a data for actual or predicted. First, we apply actual and predicted, and second, we apply actual versus predicted label. This data is test data, and the first graph is from training data. And lastly, we make a confusion matrix. And next lecture, I also explain you what is the and this is I also calculate our miscalculation of our model. You see that our model give me 100%, approximately 100% accuracy, but in real time it misclassified 10,000 images to 240 images are misclassified. This is the main bug of our model, because in real time production this is a bug. When we apply the model in some way, just like that, from if we apply some model in the OMR case, yeah, in education field, which the images are calculated for OCR purpose, and the real time OCR is performed at, the ratio is too much high, because in our case we are dealing in education institute, and we see that we have millions of digital data from OCR process. If we apply the model on that, if we apply the ratio on that millions, it means that approximately two, 3 to 4 lakh corrections are occur in such case. Now, this is the way how you evaluate your model and how you get the falsified or misclassified examples of your model. Now, I think so. It is a good example for you. Now, if somebody have a question regarding that, because in the future lectures, I elaborate deeply how the neural networks are working. That
Thank you, Azam. So I have a couple of things I'm going to add. I think the technical perspective that you take is very good. And what I have noted in so far from my interaction with students, so I've been interacting with students from Al Faisal University, and not just the medical students. I interact with the computer science students as well, and from another couple of educational institutes based in Riyadh as well. I've been communicating with students from COST, which is out there based in Jeddah. So what I my perspective is on AI and the programs that the universities have and the students and the knowledge that they're getting. So they have a lot of theoretical knowledge. But when it comes to practical knowledge, whether it's PyTorch or it's programming or it's AI model development, I feel that the practical knowledge and the implementation is 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 somewhat lacking. So, and that's why we've sort of designed these classes around that perspective, that we want students to be able to manually and practically implement all this and learn this coding and this programming. So feel free to email any questions that you may have. I'm also going to send a message out in the group that we want more attendance from the people, because we've got like maybe 20 people enrolled right now, but a lot of people messaged me privately because they were committed elsewhere, whether they have work or whether they have educational commitments. And that's fine. That's why we record the lectures so they can come back and see the recordings, even if they are not able to attend the session live. But I'm going to email them and message them personally as well, that even if they watch the lecture later, I want them to email Azam individually with any questions that they may have, and then obviously try and pursue the tasks that he gives out, because that's actually what's going to help you in the at the workplace. These are the skills that you can develop, that are really going to help you moving forward. So that's about it. If anyone has any questions, please go ahead. Azam, if you would be kind enough to send out a copy of the presentation in the WhatsApp group as well, and
Okay.
the task that you have given out, if you can please email everyone, because I want people to try and take a shot at it and then come back with feedback next week. And yeah, if you have any questions, Mustafa, I see you there. Zayan, if you have any questions, please go ahead.
Well, I don't really have any questions, but I think I have an idea because I think we lack enthusiasm, perhaps among us as interns. How about every intern writes down two questions, and then the other students are gonna try to answer it in order to be sure that everyone understood the lecture.
Sure, that's a good idea actually. I was thinking something along the same lines. So what we do in the future is during the lecture, we have the students, we make it mandatory that anyone who is attending the lecture type out two questions, and then they can send it in the chat over here. And then after the lecture ends, we can have a 10-minute question and answer session like this that we're having right now. And then we can bring up all those questions, and then we can interact amongst each other. I think that's a good idea.
Perfect. That drives us to really actually focus more.
Perfect, perfect. Yeah, that's a good idea. Azam, moving forward, let's do that. I'll send that out in the group
Um,
as well.
and lastly, I design a assignment for the people. Basically, are you seeing my screen?
Yep.
Yes.
Okay. Okay, I designed the three little assignments for you people. I take three data sets, different type of data sets. In first data set is Titanic data set, and in such way you load the data set and create a pair plot to visualize relationship between multiple numerical values in the data sets. And secondly, you create a heat map. All the examples are already given in the visualization code I am uploaded on the GitHub. And in the second question, you perform the task like Netflix dataset to understand the distribution of movies between TV shows, identify the countries producing most contents, analyze the trend of release over the year. Basically, this is other plot. You plot some dataset from Netflix. I am also giving the hyperlink where you get the dataset. And thirdly, you get the Melbourne housing market uh, analysis about that set and identify the trend in housing prices over time and their impact of location, explore the relationship between property attributes. And basically, these assignments are given to you because you people must know about some coding stuff. As Mr. Ahmed already said that basically mostly people are delivering their lot of things about AI, just like theoretical things, just like simulations and other things. But the idea of such training is that you people are trained from the market point of view. You develop your model and also implemented some models from some feasible production place. Just like that, we are making some model regarding neuro diseases in future, and we implemented such models in hospitals, clinics, and we make a GUI because the GUI, graphic user interface, is also very important from the evaluation of our model because in the learning point of view, yeah, in research point of view, the researchers are not making a GUI because they are giving several statistic reports and such like that. But in such training, in the next session part after 3 or 2 weeks, we also make some class from the building of GUI. And in next class, we also build a model and network node model uh, from taking from some other data sets like object data sets, yeah, like some other disease data sets, and the things are also very useful for you people. Now I think that these things are already uploaded by me. Uh, now, if somebody have a question regarding that, ask me, then wind up the section.
Okay, that's good. Thanks, Azam. Azam, if you could also please send this Word document with the task, the both the
I
presentation
also
and the.
I
uh,
uh, I also uploaded on the GitHub repository.
Okay, okay, perfect. But this task, if you can please also send in the WhatsApp group, because what I'm seeing at
Okay,
the back end,
okay,
because I have admin access, so I can see that not a lot of people are using their emails, the official emails. So I think they're
okay,
more communicative on WhatsApp. So because I think what's happening is a lot of people don't have the official email on their phones. They have it on their laptops and then they miss the emails, right?
okay.
So I think you should email them and also send it everything out on WhatsApp. And from now on, I will be monitoring it more carefully so that we anyone obviously everyone is welcome to attend the class, but we want people to attempt the tasks that are being given out. So, and like you said, Azam, it's very important for the personal and professional development of everyone that they learn everything from a practical viewpoint, not just theoretical. So yeah, I think that's good. Going forward, let's interact with everyone on WhatsApp. And Zayan brought up a very good point as well about the questions. So I'm going to ask everyone in the group as well to put forward two questions that they can send out in the chat, and then we can discuss it on a call every lecture. So yeah, that's good, and hopefully we get more attendance next time. So I'll start working on that. And thank you for attending, everyone. I know it was a holiday today, but thanks for joining in. And inshallah, we will see you next week. Before I let you go, let me just give you a couple of developments that we've recently had. So the RDIA and the NCIT, they are both endorsing us, and we are getting a letter of endorsement from the RDIA, which is going to help us register the business. And we are coming, I will be coming to Riyadh again after Eid, inshallah. So sometime in June, because we have the conference for neurology over there at King Saud University, where I will be presenting. I will need one or two interns with me who will help me with the presentation. And inshallah, I think it's good things ahead, and we shall all meet up in June as well. So I think it'll be good, and I will let you guys go. And inshallah, next week we will all talk to each other.
Inshallah. I'll try to be. I'll try to come to the meeting on June, perhaps.